Potential Sinkhole Locations in Pittsburgh, Pennsylvania, presented by Audrey Cronin. The Commonwealth of Pennsylvania is intermittently covered by, or contains, limestone rock. The central and eastern part of the state has limestone exposed at the surface, which through the process of dissolution leads to the formation of sinkholes in that region. The western part of the state, however, has limestone beneath the surface exposed rock. In 2007, the Pennsylvania Department of Conservation and Natural Resources created an inventory of sinkholes in east and central PA. However, despite many instances of sinkholes occurring in western Pennsylvania, the region remains unsurveyed for sinkholes. The city of Pittsburgh especially has a history of sinkhole occurrences, so for my project, I decided to focus on sinkholes within the city limits. This leads me to the question that I try to answer through this project. Where may sinkholes be located within the city of Pittsburgh, Pennsylvania? I attempted many different methods to delineate sinkholes before achieving my final results. The method that I ended up using for my sinkhole detection is as described in a 2013 publication by US GIS professionals Daniel Doctor and John Young. This paper, presented at the 13th Sinkhole Conference, describes and evaluates two methods to delineate sinkholes using a 1-meter LiDAR DEM. Although both methods determine where sinks are located, the first method uses a difference raster, while the second method uses an index. I decided to use the first method, as the publication described it as being both better at delineating larger sinkholes and having reduced misidentification. In order to delineate the sinkholes, I first needed a DEM. I downloaded the most recently available DEM of the region, a 2019 1-meter LiDAR DEM of Allegheny County, from the National Oceanic and Atmospheric Administration. I then followed the steps in the publication to delineate the sinkholes. First, I filled in the sinks, which created a fill raster. I then subtracted the original DEM from the filled raster to determine where the sinks were located. In order to ensure that the data was accurate, I first extracted all pixel values with the depth greater than 10 centimeters, as any depths below that value would be outside the vertical accuracy of the DEM. After this, I needed to apply a series of constraints to the filled-in sinks in order to ensure that I was viewing only potential sinkholes. After converting the resulting sinks to polygons, I removed all sinks with a maximum depth of less than 18 centimeters to eliminate some artificial depressions. Then, after calculating the zonal geometry of each polygon, I removed polygons with an area of less than 9 square meters to eliminate small sinks due to potential errors in the LiDAR DEM. Next, using the attributes that I had calculated in the zonal geometry table and the formula on the left, I calculated the eccentricity of the sinkholes and eliminated those with an eccentricity greater than 0.98. I then removed sinks that overlapped with the building footprints of structures in Pittsburgh, as these sinks are likely attributed to error. Finally, I calculated the roundness of the sinkholes using the formula on the left and removed all sinkholes with a roundness of less than 0.6. Here is my resulting map of potential sinkhole locations. Converting these sinkhole polygons to points gives a clearer view of where the sinkholes are located. To create my final map, I overlaid a map of geologic formations over a hillshade of the region, and placed my sinkhole location points on top. This map shows some interesting spatial patterns with the sinkholes. First, many of the potential sinkholes are located within the south of the city. As well as being shown in pink in my final map, these locations appear to align with the subsurface limestone as depicted in the limestone map shown earlier. Along with this, many of the points appear to be at the boundary between the geological formations, especially the limestone and the shale. Although I did locate potential sinkhole locations, there are some limitations with this project. The first is that the method that I had used had another step to refine the sinkhole locations, which was manually digitizing culverts that would normally be filled up when performing a fill function. Because I didn't have a culvert inventory for the city of Pittsburgh, all filled areas that were calculated due to the lack of a drainage culvert would have been eliminated when filtering for eccentricity or roundness. This may have limited the number of potential sinkholes that I delineated. The potential sinkhole locations were also not checked for in the field, which is a limitation of the resource availability for this project. Another limitation is the applicability of sinkhole detection or prediction methods from other regions. Before I had created my final sinkhole map, I attempted a different method for sinkhole detection that was originally applied to Greene County, Missouri. Despite following the exact methods outlined in the paper, the final index that I had created did not accurately reflect any semblance of a sinkhole location map. The same can be said about a method that I tried using to determine areas that were more likely to be susceptible to sinkholes. A method I followed, originally used in Kahramanmaraş, Turkey, yielded results with no correlation. Because of this, I came to the conclusion that, although there are many different sinkhole detection indices available, many are entirely location dependent and may not show results when performed outside of their original region. To conclude, I have created a map of potential sinkhole locations within the city limits of Pittsburgh, Pennsylvania. Further analysis can be done in the field to verify the presence of these potential sinkholes. If, after comparing two observations in the field, this map of potential sinkhole locations is accurate enough, then this method may be applied to the entirety of western Pennsylvania in order to create a comprehensive inventory of sinkhole locations. In the future, the raster layers that I had used to attempt a risk map can be used along with the sinkhole inventory to aid in hazard detection and to understand where sinkholes may form. Hopefully, this potential sinkhole location map can be the first step in raising awareness about sinkholes and geologic hazards, fostering a safer western Pennsylvania. Thank you for watching.